You did everything right. You optimized the keywords, built the backlinks, and structured the schema to dominate the search results. Yet when someone asks ChatGPT, Gemini, or Perplexity a direct question about your specific industry, your brand never surfaces. Instead, a competitor appears as the definitive answer, even if they have half your domain authority and no recent content. This gap between ranking performance and AI visibility occurs even when content meets every traditional standard for quality. The disparity indicates a mismatch in visibility architecture between two different types of search. Traditional search operates on an index. It functions like a massive, literal filing cabinet lookup, retrieving documents that match specific text strings. Large language models operate on parametric memory. They do not retrieve stored pages. They reconstruct answers from scratch using probabilistic weights assigned to millions of concepts. Because these systems rely on different architectures, signals designed for a filing cabinet index provide no guarantee of being encoded within a parametric memory matrix. The divergence started with Google's 2019 BERT update, which shifted the objective from matching text strings to understanding the underlying concepts within a document. Traditional keyword optimization is built for crawlers. It signals relevance by measuring how frequently a term appears and where it is placed in the HTML. Entity salience has replaced keyword count as the primary requirement for visibility within entity-centric search environments. Entity salience measures how prominently and accurately a specific concept, a person, product, or organization, is represented and connected to other concepts in your writing. If you attempt to stuff an article with target keywords, you create thin repetition that artificial intelligence systems filter out as undifferentiated noise. Vague, repetitive mentions fail because they do not establish the concrete, verifiable relationships between entities that a language model needs to formulate a citable claim. This table contrasts the approaches. Keyword density relies on term frequency and placement. Entity salience is measured by entity recognition scores and relationship density. To optimize, you explicitly define entities in your text and logically link them to known knowledge graph nodes. Entity salience is the language AI knowledge systems use to comprehend the world. Counting keywords offers no relational data, making it structurally useless for securing an AI citation. To secure those citations, you have to practice Large Language Model Optimization, or LLMO, a distinct discipline that sits directly above your standard SEO efforts. This diagram illustrates the LLMO framework. It operates on three strategic levers. The base layer is retrieval surface area. Structural signals allow systems to extract exact data chunks. The middle is training signal quality. Only highly specific, verifiable claims survive compression into parametric knowledge. The apex is citation velocity. Your claims must be cited by other publishers. Most brands invest all their resources in the retrieval layer while ignoring training signals and citation velocity. That imbalance explains why an established brand's AI footprint can lag years behind its organic search rankings. This brings us to Answer Engine Optimization, or AEO. In this environment, the entire web page is no longer the unit of optimization. This diagram shows how AEO isolates focus. Out of an entire document, the isolated, self-contained passage is the only structural unit that matters. A winning passage must state the direct answer in its very first sentence. The following 2 to 3 sentences must then provide complete, highly specific context. The critical test is that absolutely no surrounding context from the rest of the document can be required to understand that specific passage. By structuring passages cleanly, low-authority domains bypass page-level ranking constraints and surface as the definitive AI answer because their explanation is the clearest. You reinforce these passages using structured FAQ and how-to schema markup. Now, language models learn from text, not from the markup directly, but schema creates an indirect amplification loop. It feeds structured data pipelines, which secure Google-featured snippets, and those snippets disproportionately populate the training corpora of AI models. Architecting self-contained, schema-wrapped passages is the most reliable structural mechanism you have to force an answer engine to select and surface your claim. Beyond the structure of individual passages, you have to consider semantic co-occurrence. In an AI's vector space, the meaning of a concept is literally defined by its location. Language models do not read words. They process statistical clusters of concepts that frequently appear together across vast training data. This vector map shows how a brand's semantic neighborhood dictates authority. If your topic co-occurs with generic terms, the model places you in a low-value cluster. But when your content co-occurs with highly specific, authoritative entities instead, the model recalculates your position. This dense mathematical neighborhood structure drives topical authority, giving focused niche sites immense power over generalist publications. You cannot manually plot your brand's exact vector coordinates, but you can force its location by strictly controlling the technical density of the entities you write about. The shift from entity graphs to AI parametric memory is accelerating, and those optimizing for older algorithms are being omitted from current training cycles. This dashboard shows the metrics that actually define your AI memory footprint: explicit entity mentions, schema-optimized passages, and third-party citations. The execution protocol starts right now. Pick one primary pillar page on your site and audit it strictly for entity salience today. Count your named entities. Ensure that every single one has an explicit relationship defined with another entity, rather than just being vaguely mentioned. Identify the 3 passages most likely to be queried as standalone questions, and apply strict FAQ schema directly to them. Do this immediately, because the content you publish this quarter will dictate the language model training pipelines within months. Parametric models do not forget information. They simply fail to learn the existence of brands lacking structural and semantic clarity to survive compression.